All right, let's jump right into this foundational explainer on SQL syntax. If you're getting ready to work with Java Database Connectivity, or JDBC, you're basically stepping into a world where your Java application needs to talk to a database. But here's the catch, right? Java and databases, well, they don't naturally speak the same language, and that is exactly where SQL comes in. It's your vital prerequisite, literally the absolute bedrock for understanding how to properly communicate with databases through JDBC. Without mastering this syntax, your Java code simply won't have a way to ask the database to do anything at all.
So, here's our roadmap for today. First, we'll look at the universal database language. Then, we'll move into managing databases and tables. After that, we've got creating and reading data. And finally, updating and deleting data.
Okay, Section 1, the Universal Database Language.
So SQL stands for Structured Query Language. And what makes it so incredibly beautiful is that it's completely standardized. Think of it like a universal translator. It doesn't really matter if you're working with MySQL, PostgreSQL, Oracle, or SQL Server, they all understand this core language. This means you can write your database code completely independently of the underlying software. You don't have to go out and learn a totally new language just because your company decided to switch database vendors.
Now, as we get into how we actually manipulate the data, you really only need to remember this one highly memorable, kind of funny acronym. Once you grasp this, you've pretty much grasped the entire purpose of database interaction.
And that acronym is CRUD. That's Create, Read, Update, and Delete. These are the 4 core operations you can perform on any data. You create a new record, you read it back to look at it, you update it when information changes, and you delete it when you no longer need it. If you understand create, read, update, and delete, you absolutely understand the beating heart of SQL. Everything else is just details.
Moving right along to Section 2, Managing Databases and Tables.
So there's a really stark contrast between creation and destruction here. On one hand, we have the command create database EMP. It's a super simple, elegant command to spin up a brand new database named EMP. But then we have drop database EMP. That right there is the big red button. Executing a drop command requires administrator privileges for a very good reason. It permanently deletes the database and literally every single piece of data stored inside it. So yeah, definitely a command you want to use with extreme caution.
Now, safely inside our newly created EMP database, we need to logically map out our data structure. Because a database without tables is basically just an empty warehouse, right? To build it, we use the create table statement by following a few exact steps. First, we name the table. Let's go with employees. Second, we define our columns and their data types. You'll see we use int for numbers like ID and age, and varchar for text strings like first and last name. Finally, and this is absolutely crucial, we assign a primary key, in this case the ID. This guarantees that every single row in our table has a totally unique identifier.
But, just like the database itself, tables aren't always permanent. If we ever made a mistake in our structure, or just needed to totally destroy that entire table and all the employee records inside it, we'd use this simple syntax: drop table employees. Once again, it's a powerful, irreversible command that just completely wipes the slate clean.
All right, Section 3, Creating and Reading Data.
Let's actually use this. We're going to formally hire our new employee, Zara Ali, by using the insert statement. We just declare insert into employee's values, and then right in parentheses, we provide the exact data that matches the columns we defined earlier. We inject her ID of 100, her age of 18, her first name Zara, and her last name Ali directly into the respective columns of our table. Boom. Zara is now officially in the system. Of course, putting data into a database is only useful if we can actually get it back out, right? To look up Zara's file later, we rely on the where clause. This clause is your ultimate filter, and to filter effectively, you use these essential comparison operators. We have your standard equals, not equals, greater than, and less than operators, but we also have between for checking ranges, and the incredibly useful like operator, which actually lets us search for patterns within text strings. So to actually pull her file, we use the select statement. We specify exactly what columns we want to see by saying select first, last, age from employees. But the real magic happens at the very end. By adding where ID equals 100, we're telling the database to ignore every other employee and only read the exact record that matches that unique identifier. Alternatively, we could have used that like operator we just talked about, maybe searching for where first like %Zara %, to find anyone with that first name.
And what you get back is a perfectly organized representation of Zara's newly created data row. You asked for the first name, last name, and age where the ID was 100, and the database delivered exactly that slice of information right back to you. This is the read operation in its absolute purest form.
Let's bring it home with Section 4, updating and deleting data. You know, data in the real world isn't static. People grow, names change, departments shift. So what exactly happens when Zara turns 20? We need a targeted way to change her file. We certainly do not want to have to delete her entire record and go through the whole process of rehiring her in the system just to change a single number. No way. Instead, we just celebrate her birthday right in the database using the update statement. We say, update employees, set age equals 20. But pay close attention to the absolutely critical final part of that command, where ID equals 100. If you forget that where clause, you will accidentally update the age of literally every single employee in your entire company to 20. So that where clause is your safety net. It ensures we only change the age for Zara.
Finally, if Zara's life cycle at the company comes to an end, we use the delete statement. And again, notice how it is safely anchored by her unique ID. We say delete from employees where ID equals 100. This permanently terminates her specific record from the table without touching anyone else's data at all. And just like that, we've walked through the entire CRUD lifecycle for a single piece of data using universal SQL syntax.
Now that you deeply understand this universal syntax and the real power of those CRUD operations, I want to leave you with this provocative thought. You know how to write the commands, but since SQL operates completely independently of the database software, how do you think a Java application actually packages these exact text commands and sends them securely over the wire to be executed? That exact bridging mechanism is exactly what you're going to discover as you take your next steps into the mechanics of JDBC.